Watch the complete playlist on the app Pions. Download the app now.
The slab of material of dielectric constant K has the same area as the plates of the parallel plate capacitor but has a thickness 3D by 4. So let's draw this. Here this is our parallel plate capacitor. Let's put here a dielectric, and this is of thickness 3D by 4. If the total separation is D and this part is 3D by 4, how much is this part empty space? D by 4. Sir, how you got D by 4? You can subtract D minus 3D by 4. You will get D by 4. Or if you add both of them, you will get D, right? Where D is the separation between the plates. How is the capacitance changed when the slab is inserted here? So if this is 3D by 4 and this is D by 4, in place where you have placed this dielectric slab, there will be change in electric field. Once again, I am repeating this. So electric field changes E naught by K, where K is the dielectric constant of this. And here the electric field still remains E naught. Why? Because there is no dielectric here. So what will be the voltage across the dielectric? Sir, voltage across the dielectric will be V1. That will be electric field across the dielectric, which is E naught by K, into that separation, which is 3D by 4. Let me repeat again. The voltage is nothing but electric field into distance. So electric field across this dielectric is E naught by K, and this distance is 3D by 4, right? Now what's your voltage V2? V2 is the voltage across this empty space across the capacitor, and the electric field across that empty space is E naught into the separation is D by 4. So net voltage will be V, which is equals to V1 plus V2 by superposition principle. Let's add both of them. So it will become E naught by K into 3D by 4 plus E naught into D by 4, right? Now what's our electric field for a parallel plate capacitor in between the two plates? So sigma by epsilon naught. Let me repeat. Sigma by epsilon naught is the electric field in between the plates of the capacitor. How we got this? Go through the derivations. Clear? So this will be our sigma by epsilon naught. In place of electric field, I am putting here E naught is sigma by epsilon naught. Clear? So this is our voltage. Now voltage is, if this is our voltage, what we will do? Now we will first we will put the value of sigma. So let me put here from first chapter, sigma is nothing but surface charge density. So this will be Q by epsilon naught K into A. Q by A is sigma into 3D by 4 plus Q by epsilon naught A and D by 4. Q by A is sigma. Now what is common between both? Let's see. Sir, Q is there in both the terms in the numerator. D is also there in the numerator. Epsilon naught is there in both them. A is there in both of them. 4 is there in both of them. So what we left with here? 3 by K plus 1. Now this can be written here as QD upon 4 epsilon naught A K plus 3 plus K upon K. Correct? This is our voltage. If this is the voltage across this capacitor, what will be the capacitance? Sir, capacitance will be simply charge upon voltage. So what is our voltage? Q upon voltage. Q, D and 3 plus K. Remaining one will go up 4 epsilon naught A K. Let's remove this with this. So we left with capacitance value C, which will be equals to epsilon naught A by D 4K upon K plus 3. Now what is epsilon naught A by D? So it was the initial capacitance of the capacitor C naught, if you want to write, or you can leave it as the previous one. So C naught is the initial capacitance, which is without the dielectric slab, epsilon naught A by D. Because of the slab, it became this one. Done. This is our correct answer.